In this lesson, we will be solving quadratic expressions or quadratic equations by factoring. Let's take a look at an example. So we have 9t squared minus 12t plus 4. So the first thing that we would like to do is to make sure that our function is set equal to 0. Once it is set equal to 0, we will factor the quadratic. Let's take a look. We have 9t squared minus 12t plus 4. We don't have a common monomial factor, so let's look for a special pattern. So we do have 9t squared, which is a perfect square, and we have positive 4, which is a perfect square. So it looks like our perfect square trinomial pattern would work. The square root of 9t squared is 3t, and the square root of 4 is 2. And we need our minus sign since that's the sign of our middle term, and that would be the quantity squared. We could also write it as 3t minus 2 and 3t minus 2. Now, in order to solve, we use what's called the zero product property. So we set the factor equal to 0, each one of them, and then we solve. And since in this case the two factors are exactly the same, we only need to do one of them. It's a simple equation, so we're going to add 2 to both sides. We have 3t is equal to 2. And when we divide both sides by 3, we get a solution of t is equal to 2/3. We can check our solution by plugging it back into our equation and solving to make sure that it is correct. Let's take a look at example B. In example B, we do not have our quadratic equal to 0, so we need to do that first. It doesn't matter if you have the x squared on the right or the left. I like my x squared to have a positive leading coefficient, so I'm going to leave it where it is and subtract 3x from both sides. So I have negative 6 is equal to x squared minus 3x minus 10, writing my quadratic in standard form. Now I need to get rid of the 6. I'm going to add 6 to both sides. So I have 0 is equal to x squared minus 3x minus 4. Now I have my quadratic expression set equal to 0, and I'm going to factor it. So I will set up my 2 parentheses. Since my leading coefficient is 1, I know that x times x gives me x squared. And for my 4, I can either use 2 and 2 or 4 and 1. I'm going to go with 4 and 1. And since my 4 is negative, I want to know what two numbers can I multiply together that give me negative 4, but when I add them together, I get negative 3. So that's going to be a negative 4 and a positive 1. To finish solving, we set each of these equal to 0, and we solve. So I'm going to add 4 to both sides, so I know that x is equal to 4. And when I subtract 1 from both sides, I know that x is equal to negative 1. These are my two solutions, and you can quickly check by substituting into the equation and making sure that they are true. Here's our next example. Find the zeros of y equals 3x squared plus 14x minus 5. Remember in our vocabulary that the word zeros is also our term for solutions. So we're going to take our first step by replacing the y with 0, and then we're going to factor to solve. First, I take a look if we have any common monomial factor. 3x squared, 14x, and negative 5. We don't. So we are going to factor, and it doesn't appear to be a special pattern. So we say to ourselves, what can we multiply together that's going to give us 3x squared? And that would be 3x and x. And what can I multiply together that's going to give me 5? 5 and 1. So I have to decide if the 5 should go here or if it should go over here. The reason I'm picking over here is because I want to multiply the 3 times the 5, which gives me 15x. and the 1 times the x, which gives me 1x. And I can use these two in combination to give me my middle number, my middle term, which is 14x. If I take 15x, making that positive, minus x, will give me 14x. Now I'm going to set each of my factors equal to 0 to finish solving. So I have 3x minus 1 is equal to 0, and I have x plus 5 and set it equal to 0. I solve by adding 1 to both sides and then dividing by 3. So x is equal to 1/3. Here I subtract 5 from both sides, and I have x being equal to -5. These are my two solutions, which are also called the two zeros. In my next example, I have 8x squared plus 5x minus 4 equals 2x squared minus 8x plus 1. I need my function to equal 0. So the first thing I'll do is to subtract 2x squared from both sides. That's going to leave me with 6x squared plus 5x minus 4 is equal to -8x plus 1. Then I'm going to add 8x to both sides. So I have 6x squared plus 13x minus 4 is equal to 1. And then I'm going to subtract 1 from both sides so that I have it equal to 0. Now, it would be a great idea, if you can see the shortcut, to simply do all of that in one step. I could have subtracted 2x squared, added 8x, and subtracted 1 all at the same time. So now I have 6x squared plus 13x minus 5, and it's equal to 0. So I'm going to factor. And I could use for 6x squared 6x and 1x, or 2x and 3x. I'm going to try 2x and 3x. And then I need to figure out what to multiply to get 5. So I have 5 and 1. If I put my 1 here and my 5 here, I'm going to get 2 times 5, which is 10, and 3 times 1, which is 3. That gives me 13x, but the problem is that I need one of them to be positive and one negative. So I'm going to reverse those and put my 5 here and my 1 here. Because when I multiply my outside terms together, I get 2x, and my inside terms together, I get 15x. And I want one of these to be positive and one of these to be negative in order to get my middle term of 13x. So -2x plus 15x gives me 13x. So I want this to be plus and this to be minus. Now we're going to set each of those equal to 0. So I have 2x plus 5 equal to 0, and I'm going to solve by subtracting 5. And then I'm going to divide by divide by 2. So my first solution is going to be -5 over 2. Then I will set the second one equal to 0, 3x minus 1 equal to 0. I'm going to add 1. So I have 3x is equal to 1, and then when I divide by 3, I have x being equal to 1/3, and that would be my other solution. Let's take a look at the next example. Notice in our next example that I have quite a bit going on. And in order for us to be able to combine like terms together and get this equal to 0, the first thing we have to do is to actually square these binomials or multiply them out. So I will write these out in the longhand first. X plus 1, the quantity squared, means that I have 2 of those binomials. Then I have -3 times x minus 1, the quantity squared, which means I have 2 of those binomials. And that's equal to 6. So I'm going to multiply x plus 1 times x plus 1. So that's going to give me, When I multiply, I'll have x squared plus 1x plus 1x plus 1. Then I have negative 3, and I'm going to multiply those two binomials together. And I have x squared minus 1x plus 1 is equal to 6. So if I combine like terms in our first section, that gives me x squared plus 2x plus 1. And then if I combine these together, that gives me a negative 2x. So I'm going to distribute the 3. So I get negative 3x squared. Negative 3 times negative 2x is a positive 6x. And negative 3 times 1 is negative 3. And that equals 6. Then I'm going to combine like terms together. So I have x squared and a negative 3x squared. That gives me negative 2x squared. I have a 2x and a 6x, which combines to be 8x. And I have a 1 and a negative 3, which combines to be negative 2. And I still need to move my 6 to get my quadratic equal to 0. So now I finally have negative 2x squared plus 8x minus 8 is equal to 0. When I factor, I'm going to look for the greatest monomial factor, or the common monomial factor, and that happens to be negative 2. So I'm going to divide each of my 3 terms by negative 2. And now I'm going to factor, and if I take a look at my factor, I have a leading coefficient of 1. So I have 1x squared, and then what two numbers can I multiply together that give me negative 4? But when I add them together, I get negative 4. Excuse me, that multiply to be positive 4, and when I add them, I get negative 4. So that's going to be a negative 2 and a negative 2. Since these factors are the same, we can set one of them equal to 0. And then your question might be, well, what about this leading coefficient? Well, when we're solving, you could divide both sides by negative 2, and when we do, the result is still that this is equal to 0, because 0 divided by negative 2 is 0. So basically, when you have a leading coefficient that is just a number, we don't have to worry about that. So we're going to set this equal to 0, x minus 2 equal to 0, and add 2 to both sides. So our solution after that long problem is x is equal to positive 2. Okay? Let's review. One thing I would like to mention is that when we are solving, if you were to get a situation where we had something like this, where we have 3v and then v minus 6 were my factors, and I set them equal to 0, because our leading coefficient contains a variable, we do need to set that expression equal to 0 to solve, as well as the v minus 6 equal to 0 to solve. So in this case, when I would divide both by 3, one of my solutions would be v is equal to 0, and one of the solutions would be v is equal to 6. So unlike the previous slide, where my leading coefficient was just a constant or a number value, in this case you would need to set that factor equal to 0 if it is a variable. So please make sure your quadratic function is in standard form and you have it set equal to 0. Then factor, and then set each of your factors equal to 0 and solve. Please remember to do the reflection.